This is a continuation of our study on solving higher order polynomial inequalities. And in these examples, and there'll be about 4 or 5 examples, but in these examples, you're going to solve each inequality algebraically. So notice it said the word algebraically, and basically, just like in the previous lesson with this, you're going to use these steps, solving polynomial inequalities. So as you begin solving these polynomial inequalities, remember the first step is to make sure it's in standard form. So you want 0 on one side. And so if you notice on this example, you do have 0 on one side. It is in standard form. So you have this higher order polynomial inequality. So higher order meaning that it's higher than a quadratic. So notice the largest exponent you see here is cube. It is in descending order, so remember when you factor, which is going to be the next step, so you want to identify your zeros, and you're going to identify your zeros by factoring the polynomial. So when I factor this polynomial, notice the GCF here is x. I can factor out an x, and let me go ahead and do that on this side. So I'm just go ahead and rewrite this over. So I get 2x squared, 3x cubed minus 2x squared minus 15x. And so I'm going to factor this. I'm going to factor out an x. And when I factor out an x, I get x times x squared minus 2x minus 15. Now you want to factor this completely. And so this trinomial right here, I can go further with factorization. So I get x times, and when I factor the x squared minus 2x minus 15, I get x minus 5, that's a 5, times x plus 3. All right, so x cubed minus 2x squared minus 15x can be factored as this. So these three factors. So your factors are x, x minus 5, and x plus 3. So I'm going to go ahead and rewrite that here. So I get x times x minus 5 times x plus 3 is greater than 0. So don't forget greater than 0. All right, now the next thing you want to do, remember you're on that second step where you want to identify your zeros. So to identify the zeros, we're going to set each of these factors equal to 0. So we want to find out what makes this left-hand side equal to 0. So your zeros are, and remember another word for zero, sometimes they'll use the word critical numbers, sometimes they'll use the word boundary points. So if I set each of those factors equal to 0, I get x equals 0. That's our first factor, so x is already by itself. So 0 is one of my 0 is one of my zeros. The next one, x minus 5 is equal to 0. So when I solve this linear equation for x, I get x to be 5. So there's the other 0. And then x plus 3 is equal to 0. So I get x to be negative 3. So there's the other 0. So what you just found is that if you substitute each of these numbers, 0, 5, and negative 3, into either this expression, this trinomial, or the factored part, this left-hand side will be equal to 0. So that's what you found. Those are important because once you find your zeros, you're going to put those on the number line. So I'm going to put those on the number line, which is the next step. To next step, remember to draw the number line with the zeros labeled. So you put these on the number line, which you notice, and you have to put them in order. So you have negative 3, 0, and 5. So what you've done was you've separated this number line into intervals. So you have this interval, the interval between negative 3 and 0, the interval between 0 and 5, and the interval that's greater than 5. So from negative infinity to negative 3, you have your first interval. From negative 3 to 0, your second interval. From 0 to 5, your third interval. And then from 5 to infinity, your fourth interval. Now, what you going to do now is determine which of those intervals are going to be solutions to this inequality that you're trying to solve. All right. So also keep in mind that these numbers here, negative 3, 0, and 5 are your zeros. So that means if you substitute those numbers into either this polynomial or the factored part, you'll get 0. So I'm going to put zeros here, meaning that When I substitute -3, I get 0. When I substitute 0, I get 0. When I substitute 5, I get 5. That's how you found those zeros. So then the next thing you're going to do, once you do that, is you're going to determine your test points. So you're going to pick a point between -infinity and -3 that's in this interval. It doesn't matter which test point, does not matter. So I'm going to choose -5, let's say. And it's always easiest to choose an integer. Choose an integer. It makes things a lot easier. So from -3 to 0, there's only two integers between -3 and 0. There's -2 and -1. So let's just choose -2. Between 0 and 5, let's choose, let's say 2. And then from 5 to infinity, let's say 6. So those are my test points. Okay? Now, what you're trying to do is determine which of those intervals will provide solutions. And when I say solutions, I mean what values of x will make this left-hand side greater than 0. Remember, greater than 0 means positive. Greater than 0 means positive. Now, since there's no equal sign, that's a strict inequality. Since there's no equal sign, that means that when I put this in interval notation, I'm going to have parentheses around those zeros. Parentheses. So I'm going to call it PAR from now on to save some room. So parentheses, parentheses, parentheses. You'll see what I mean by that when I get to that point. All right, so let's start talking about those zeros. So I'm going to go ahead and use another sheet of paper to do that. So it is always easier. It is always easier to substitute those zeros into the factored part. Now, assuming you factored it correctly, you can go back to the original as long as you have 0 on that side. So you can go back to the original if you need to, but it's always easiest to go back to the factored part. Okay? All right, so let's go ahead and I'm going to put this here. So the first one I'm going to test is a test point x equal -5. So test point x equal -5. So I'm going to go back and I'm going to put that in the factored part. So let me go ahead and kind of line it here. So here's my factored part here. So when x is -5, I get -5 times -5 minus 5 times -5 plus 3. And so really all you're interested in doing is determine what sign this is. So I have a negative, -5 is negative, -5 and a -5 is a -10, that's negative. -5 plus 3 is a -2, that's negative. So a negative times a negative is a positive times a negative is a negative. So that means, remember what that means? That means if I substitute any real number between -infinity and -3, between -infinity and -3, that's going to make the left-hand side a negative number. But that's not something I want. I want the left-hand side to be a positive number. Greater than 0 means positive. So that's not going to be a solution. This interval is not going to be one I'm going to use. Now, if you had substituted for the test point, if you had gone back and used the polynomial, you need to be careful. You could have used your polynomial. You would have, since my test point's negative, you need to put that in parentheses. So you would have said -5 cubed minus 2 times -5 squared minus 15 times -5. All right, and you want to see what number this is. So using your calculator, make sure you put that in your calculator correctly with the parentheses. You need to make sure you are using the parentheses. Otherwise, if you don't use parentheses correctly, you're going to end up with a wrong value. So when using your calculator, you need to say parentheses -5, close the parentheses, cubed. See how that looks? Okay, then minus 2 times parentheses -5, close the parentheses, and that's being squared, minus 15 times in parentheses -5, and then press equal, and I get -100, which is negative, which is what we had here. Okay, so just be careful when using the polynomial itself, because parentheses are going to be important in some cases, especially when you have a negative value for x, for your test point. Okay, so then let's go to the second test point. So my second test point is x equal negative 2. So I'm going to go back, and in place of the factored part, I'm going to substitute negative 2 and see what that product is. So I get negative 2 times negative 2 minus 5 times negative 2 plus 3. So this is negative. So I'm going to just put it like this. Negative times a negative 2 to negative 5 is negative. A negative 2 plus 3 is positive. So a negative times a negative is a positive times a positive is a positive. So no matter what real number I choose between negative 3 and 0, this product is going to be positive, and that is something I want. So I'm going to use that as one of my solutions. So that interval will be a solution. Then you go to the next test point. The next test point is 2, so x equal 2. So x equal 2. And so when I substitute x equal 2 into this factored part, I get 2 times 2 minus 5 times 2 plus 3. So that's positive. 2 minus 5 is a negative, negative 3, and then 2 plus 3 is positive. So a positive times a positive is a negative. So no matter which test point I use between 0 and 5, which real number I use between 0 and 5, any real number between 0 and 5 will make this left side a negative number. And that is not something I want, because I want this side to be positive. And then finally, we use the test point x equals 6. And so when I substitute that into the factored part, I get 6 times 6 minus 5 times 6 plus 3. Well, that's a positive times a positive times a positive, and a positive times a positive times a positive is a positive. All right, and so no matter what real number I choose between 5 to infinity, when I substitute that value of x into the original problem, this product is going to be positive. So this is a solution. All right. Now let's go ahead. Oh, and by the way, just because you've seen that it alternates, don't think it's always going to be that case. All right. So you got to be careful. It's not always true. It doesn't always alternate. There are polynomial inequalities where it is not going to alternate. So be careful. Okay, so therefore the easy part now is to determine the solution. So your solution will be those two intervals right here that I have checked off. And notice there's no equal sign, so that's why we put parentheses here. So you're going to say negative 3 to 0, parentheses, union, make sure you use a union symbol, union, and then 5 to infinity. And that's it. So any real number that's in one of those intervals will be a solution to the original problem. Okay. So that was number 1. Now let's look at number 2. So number 2, we have this for number 2. Let me see. So this will be number 2. All right, so number 2, we have this. We have x to the 4th minus 5x cubed is less than or equal to negative 4x squared. So x to the 4th minus 5x cubed is less than negative 4x squared. All right. Okay, so first thing we're going to do is we're going to put this in standard form, right? Because you have to have 0 on that other side. Remember, you got to have 0 on the other side, put in standard form, and then we're going to find those zeros. So we're going to have to factor that polynomial that we end up with. So we got to bring this negative 4x squared over. So I get x to the 4th minus 5x cubed plus 4x squared is less than or equal to 0. All right, so let's go ahead and factor this. I'm going to rewrite this on the side. So I get x to the 4th minus 5x cubed plus 4x squared. All right, and so I can factor out an x squared here. So that's my GCF, x squared. So when I factor out an x squared, I get x squared times x squared minus 5x plus 4. And now I can factor this trinomial further. I get x squared times x minus 4 times x minus 1. All right, so this polynomial can be factored using these factors. And so I have two factors of x. That's what this says. I have a factor of x minus 4, and I have a factor of x minus 1. And I want to find all values of x that will make this product negative. Less than 0 means negative, right? And then knows the equal sign, so negative or 0. So my solutions are going to be any number, any value of x that's going to make this product or this polynomial right here that says less than 0, negative or 0. Okay, so first thing we got to do is we got to find the zeros. So let's find the zeros. So the zeros are, and you're going to set each of those factors equal to 0. So if you notice the first one, there are two factors of x right here. So if I set that equals 0, it's very easy to see that the only real number that makes x squared 0 is when x is 0. So there's one of your zeros. The other 0, you're going to set x minus 4 equal to 0, so that's going to be x equal 4. So there's your other 0. And then your other 0, you're going to set x minus 1 equal to 0, so that's going to be x equal 1. So those are your three zeros, 0, 4, and 1. And so you're going to put those zeros on the number line. You can put those zeros on the number line. And so when I do that, when I put those zeros on the number line, I get, make sure you put them in order, I get 0, 1, and 4. Okay? And notice that when I put those zeros on the number line, when I put 0, 1, and 4 in the number line, I get don't forget you get that zeros here. When x is 1 you get 0, and when x is 4 you get 0. And notice there is an equal sign here. There is an equal sign here, so you're going to use brackets on these. Okay, brackets on these. All right. Okay. So let's continue on. So now we're going to use test points. Now when we use test points, you have to. It's always easiest to use integers that's in those intervals. So notice that those three zeros divided the number line into four intervals: the interval from -infinity to 0, the interval from 0 to 1, and the interval from 1 to 4, and the interval from 4 to infinity. So these intervals will determine what the solution is, and we're going to use test points. So it's always easiest to use an integer as your test point. Sometimes you won't be able to, but if you can, it's the easiest thing to use, easiest number to use. So from -infinity to 0, I'm going to use -1 as my test point. Now there is no integer between 0 and 1, so I'm going to have to resort to 0.5. And then from 1 to 4, I'm going to use 2, and then from 4 to infinity, I'm going to use 5. Okay, and so now I'm going to go and substitute those test points into the factored part here. I'm going to go ahead and move this over. So let's see. So right here, let me kind of show it. So this factored part here. So your test point. So the first one is x equal -1. So when x is -1, now be careful, this is -1 squared. That's what you see here, right? All right, that's important. Times -1 minus 4 times -1 minus 1. So you got to be careful with that one. Now -1 squared, -1 times itself is positive, so that's a positive number. A -1 and -4 is a negative number. A -1 and -1 is a negative number as well. It's -2. So a positive times a negative is a negative. A negative times a negative is a positive. So that's a positive. So what I found is that any number between -infinity and 0 will make this product a positive number. But I want this product to be negative or 0. Okay? So that's something I'm not going to use. Then I go to the next test point, 0.5. So x equal 0.5. And so when I substitute 0.5 into this factored part, I get 0.5, 0.5, that's 0.5, squared. Let me go ahead and rewrite it over. 0.5 squared times 0.5 minus 4 times 0.5 minus 1. Okay? Now listen carefully. So when I do that, a positive number squared is still positive. 0.5 minus 4 is a negative number. Oops, negative number. And 0.5 minus 1 is also a negative number. So a positive times a negative is a negative. A negative times a negative is a positive. So that's positive as well, right? So that's one situation. Remember where it doesn't alternate? It's positive, positive. So remember, not all of them will alternate. Okay, so then I go to the next test point, which is x equal 2, right? X equal 2. And so I substitute that into the factored part. And so I get 2 squared times 2 minus 4 times 2 minus 1. Well, 2 squared, that's positive. 2 minus 4 is negative, and 2 minus 1 is positive. So a positive times a negative is a negative. A negative times a positive is a negative. So no matter what real number I choose between 1 and 4, when I substitute any of those real numbers between 1 and 4 into this factor part or into this polynomial here, it's going to be negative, which is something I want. So I'm going to check this off and put a little arrow to help me remember that that's going to be one of my intervals. And then when x is 5, your last test point, if you choose x equal 5, I get, and then make sure I'm going to go ahead and substitute into the factored part. So I get 5 squared times 5 minus 4 times 5 minus 1. And so 5 squared is positive, 5 minus 4 is positive, 5 minus 1 is positive, right? So a positive times a positive times a positive is a positive. So no matter what real number I use between that's greater than 4, that product is going to be positive. Or if I substitute here, that polynomial is going to be positive. But that's not what I want. I want negative or 0. So that's something I'm not going to use. So here's what we have. I have a check on this interval only, but you got to be careful. Remember, you want to find any real number that's going to make this right here negative or 0. Okay? So here's where you're going to make a mistake if you're not careful. You're going to say this. You're going to say, because of prior experience, that's what you did. Wherever you saw a little check, you use that. So you said 1, 2, 4, right? And you saw an equal sign, so you put a bracket. So you said bracket 1, comma 4, right? But there's a problem. And you put bracket because when x is 1, you get 0. This is 0, right? Because if you can even look at it right here, 1 minus 1 is 0, and 0 times all of this is going to be 0, and 4 here as well. But where else is your 0? Your 0, you get a 0. This is 0 when x is 0 as well. So here's how you have to write this. You see that 0 right here is just one number. So you have to say this. You have to say the element 0 union this interval. So that's a little tricky one right there. That's a little tricky one because there's the only interval is this one. So that's the only interval you see. But you also know that the number 0 is also a 0. So you have to use it because of that equal sign. Okay? All right, so that one was a little bit tricky because of that fact. All right, now let's look at number 3. Number 3, we have this for number 3. So we have, all right, number 3. All right, here's number 3. We have x plus 5 squared times x minus 3 times x plus 2 is, let's say, greater than 0. All right? Okay. All right, so when I solve this inequality, it's already in factored form. I already have 0 on this side, so I just need to find my zeros. And I want to find all real numbers that will make this product greater than 0, meaning positive. And notice there's no equal sign here, right? No equal sign. Okay, so let's find the zeros. So the zeros are, okay, so if I look at the first factored part, there are 2 factors of x plus 5. See that? So I need to find out where's that 0. Well, x plus 5 squared is equal to 0 when x plus 5 equals 0. And x plus 5 is equal to 0 when x equals negative 5. So there's one of your zeros. Your next 0 will come from the next factor, which is x minus 3 is equal to 0. So that's going to be when x is 3. And your next one is going to be x plus 2 is equal to 0, and that's going to be when x equals negative 2. So those are my three zeros. So I'm going to put those on the number line, just like I did in the past. And let's put them in order. So negative 5 is going to be first, then negative 2, and then 3. And notice that those three zeros divide the number line to 4 intervals. 1, 2, 3, 4. So the interval from negative infinity to negative 5, the interval from negative 5 to negative 2, the interval from negative 2 to 3, and the interval from 3 to infinity. Notice that those zeros actually make the left-hand side 0. So I'm going to put 0 there. All right. Now on the other real numbers, it's either going to be positive or negative. So that's what we're trying to determine using a test point. So I'm going to use a test point, let's say between negative infinity and negative 5, let's say negative 6. And then over here, it's always easiest to use a integer if possible. So I'm going to use negative 4 here. And then here, I'm going to use 0. 0 is also easy to use if you can use it as a test point. And then here I'm going to use 4. All right. And so now let's go ahead and find out whether this interval is positive or negative, this interval is positive or negative, and so on. And remember, I'm trying to find the intervals that are positive. Okay, so let's go ahead and use the first test point. And we're going to go back to it's already in factored form, so that's easy. So the test point, x equal negative 6. So when x is negative 6, I get this. I get negative 6 plus 5 squared times negative 6 minus 3 times negative 6 plus 2. Well, negative 6 plus 5 is a negative 1. Now be careful. A negative 1 times itself is positive, so you got to be careful there. That's actually positive. Negative 6 and negative 3 is negative. Negative 6 plus 2 is also negative. So a positive times a negative is a positive number. So what that means is that any number, any real number between negative infinity and negative 5 will make this product positive, which are going to be solutions because I want positive. So put a check mark there. Then we do negative 4. So x equals negative 4. And so when I substitute negative 4 into here, I get negative 4 plus 5 squared times negative 4 minus 3 times negative 4 plus 2. Well, negative 4 plus 5 is 1, and 1 times itself is positive. So this is actually going to always be positive because you're squaring it. So be careful when you do that. Negative 4 and negative 3 is a negative 7, so that's negative. Negative 4 plus 2 is negative. That's negative 2. So a positive times a negative is a positive. So what I found there is this. Well, in that interval as well, from negative 5 to negative 2, that is going to be positive as well. And no matter what real number I use, when I substitute into the original problem, this side is going to be positive, which is something I want. So that's also going to be a solution. So again, you have a situation where it doesn't alternate. You have positive, positive. Then you go to the next one, 0. When x is 0, let's see what happens. So when x is 0, you substitute into the factored part, you get 0 plus 5 squared times 0 minus 3 times 0 plus 2. And 0 plus 5 is 5. 5 squared is positive. 0 minus 3 is negative. 0 plus 2 is positive. So a positive times a negative times a positive is a negative. So what you found there was that any real number between negative 2 and 3 will make this product negative, which is not what you want. So I'm going to X that out. So far I have these intervals that are going to give me the solutions to this inequality. So then we go to x equal 4, the next test point, x equal 4. So then you do that, and let's see what we get. So when x is 4, I get negative 4 plus 5 squared. We're substituting it into this right here, times negative 4 minus 3 times negative 4, I'm sorry, positive 4, right? This is positive 4, excuse me. Positive 4 plus 5 squared times positive 4 minus 3 and positive 4 plus 2. So 4 plus 5 is positive. A positive times itself is still positive. Negative 4 minus 3 is positive 1. Negative 4 plus 2 is positive 6. So a positive times a positive times a positive is a positive. So what that means is that any real number that's greater than 3 will make this product positive, which is something I want. Okay, now we got to be careful because I have 3 intervals here, but there is no equal sign. Okay, so here's how you have to be careful with this. Okay, so I have the interval. Now here's how you can write your solution, and you got to understand why we do it this way. So your solution, you're going to say negative infinity to negative 5. Now remember, there's no equal sign, right? So we have to put parentheses, 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 because negative 5, negative 2, and 3 are not solutions. They're not solutions because there's no equal sign here. All right, so you got to be careful. You see, when you substitute, let's say 3, when you substitute 3 minus 3 is 0. 0 times all of this is 0, but is 0 greater than 0? The answer is no. So 3 is not a solution, negative 2 is not a solution, and negative 5 is not a solution. Okay, so how do you write the solution here? You have to be careful with this one right here. You have to be careful because the solutions, the intervals are right next to each other. They're adjacent. So you have to say this. You have to say negative infinity to negative 5 in parentheses union, and then negative 5 to negative 2. So far, that's what we have. Now, make sure you understand why we don't say negative infinity to negative 2, because negative 5 is not a solution. Negative 5 is not a solution. If you put, and I'm going to go ahead and say that here, if you wrote negative infinity to negative 2, if you wrote it like this, you're saying negative 5. See, negative 5 is in here, right? But negative 5 is not a solution. Negative 5 is not a solution because when you substitute negative 5 in here, negative 5 plus 5 is 0. 0 times all of this is 0, but 0 is not greater than 0. 0 equals 0. So that's why you have to be careful. That's why you have to look to see, well, is there an equal sign or is there not an equal sign? So all of that plays into your solutions. And then finally, you're going to say union and then 3 to infinity. So that's your solution. All right. Now, what I want to do now is I want to do this. I want to do that same problem. Right here that we just did, just to show you something. X plus 5 squared, x minus 3, x plus 2, but now make it x is greater than or equal to 0. All right, so the only difference was I made that greater than or equal to 0. Now, let me say this. All these steps right here, all of this, when you found your zeros, all those are correct. Okay, so I'm just going to put right here, the zeros are, remember we found them in the previous problem, negative 5, 3, negative 2. We put that on the number line just like we did in the previous problem, so all this is still the same. All that's still the same. Negative 5, negative 2, that's negative 5, negative 2, and 3. We have 0 here, 0 here, 0 here, because those numbers make this left-hand side 0. And when we do the test points, it's still the same. This is still positive because that hadn't changed, right? That has not changed right here. The only thing that changed was the equal sign. So this is positive, this is negative, and this was positive. Okay, that's the only thing that changed was the equal sign. This didn't change, so all of this stays the same. All right, And then notice though, now is this. So there's an equal sign. So remember, if there's an equal sign, you're going to use bracket, right? So those are actual solutions. You're going to use those. Those are going to be solutions. You have to use those because those numbers are solutions because of the equal sign, equal to 0. And I'm still right now. See how we right here we put positive. Now you're going to say positive or what else? You want this product to be positive or 0. So that's one of the changes there. So positive. Now this is going to be positive or 0 because it's equal to 0. All right. So positive, I'm going to use it. Positive, I'm going to use it. Negative, I will not. Positive, I will. Now here's how your solution is going to look. And see how different it is from this one. Okay, so my solution will be from negative infinity to negative 2. I'm sorry, with the bracket, excuse me, bracket, because negative 2 is a solution. So negative infinity to negative 2. Notice is different than this one because you have to use, for this problem here, remember, you have to say this way. You have to say this way because there's no equal sign. Now you can go directly and say from negative infinity to negative 2. Do not write it like this. Don't write it as, and let me go ahead and put it here. Don't write this as this. Don't say negative infinity to negative 5 bracket, union bracket, negative 5 to negative 2 bracket. Don't say that. You need to recognize that this is this. You must say this. Okay? All right. And then you're going to say union, and then the next solution is from bracket 3 to infinity. All right, so that's how those two differ. Notice what it looked like when you had an equal, did not have an equal sign, and notice what happened when you did have an equal sign. Okay? Notice those are brackets, though, not parentheses right here, because 3 is actually a 0. 3 is actually a solution, I should say. 3 is a solution because of the equal to 0. Okay, and then finally, let's look at number 5. So number 5, let's suppose we had this one for number 5. Let's see. Okay, so we have let's say we had x minus 2 squared times x minus 3 cubed times x plus 1 is greater than or equal to 0. Let's say that. Okay? All right. So it's in factored form, so that's a nice one. 0 is already on the other side, so we just got to find the zeros, right? So the zeros are, so to find the zeros, you're going to set each of those equal to 0. So I have x, 2 factors of x minus 2. So x minus 2 squared. I want to find out when that's 0. Well, that's 0 when x minus 2 is 0. And x minus 2 is 0 when x is 2. So 2. Next one. I have 3 factors of x minus 3. So that's equal to 0 when x minus 3 is 0, meaning x has to be 3. And the next one is x plus 1 is equal to 0. Well, that's 0 when x equal negative 1. So those are your 3 zeros. You put that in a number line. And when I put that in a number line in order, I have negative 1, 2, and 3. So notice those 3 zeros, and those are zeros because when I substitute negative 1, 2, and 3, this product is 0. That's how I found those zeros. And so those 3 zeros divide the number line into 4 intervals. Negative infinity to negative 1, negative 1 to 2, 2 to 3, 3 to infinity. So we got to determine which of those intervals are solutions to this inequality. And I want the values of x, so the solution will be any number in which this product is greater than 0, meaning positive, or equal to 0. Okay? So I want you to realize that we already know the values of x that make it 0. So we already know some of the solutions. We know this is a solution. So we're going to have to use a bracket. We have to include it. We know this is a solution, right? We have to include it, and we know this is a solution as well because of the equal to 0. So those zeros are actually solutions. All right, test points. Let's pick a test point between negative infinity and negative 1. So let's say negative 2. Between negative 1 and 2, there's only two integers, 0 and 1, and let's use 0. Between 2 and 3, there are no integers. There are an infinite number of real numbers here. So let's use 2.5. And then for 3 to infinity, let's use 4. All right, so now let's go ahead and determine the the zeros. I'm sorry, determine the values of these intervals when I use those zeros. So okay, I need to get another sheet of paper. Okay, so all right, so let's go ahead and determine the values of those intervals, the signs of those intervals at those test points. So let's use the first one, x equal negative 2. So I'm going to go here. Let me go ahead and align it a little bit better. So test point. So my test point, x equal negative 2, right here. So let's go ahead and substitute into here. So I get negative 2 minus 2 squared, negative 2 minus 3 cubed, negative 2 plus 1. Negative 2 and a negative 2, no matter what number that is, and when I square it, you do realize that if this is negative or positive and I square it, I get positive, right? Okay, because it's raised to an even power. Negative 2 minus 3 is a negative number. A negative number raised to an odd power is still negative. Negative 2 plus 1 is a negative 1, so that's negative. So a positive times a negative is a negative. A negative times a negative is a positive. So no matter what real number I choose in this first interval, it's going to make this product positive, which is something I want. Let's go to 0. Test point 0. So if I use x equals 0 next, and I put that into the factored part, I get 0 minus 2 squared, 0 minus 3 cubed, 0 plus 1. 0 minus 2 is negative. A negative raised to an even power is still positive. 0 minus 3 is negative. A negative raised to an odd power is still negative. 0 plus 1 is positive. A positive times a negative is a negative. And then a negative times a positive is a negative. All right, so I have negative here, right? Okay, so I have negative. Okay, so then what I found, remember, is that any real number between negative 1 and 2, when I substitute into this polynomial, will make this product negative, but I want this to be positive, greater than 0 or 0. So I'm not going to use that one. Then we go to 2.5. So x equal 2.5. So let's see what we get when we do that. So x equal 2.5. So I get 2.5 minus 2 squared times 2.5 minus 3 cubed, 2.5 plus 1. That's 2. Let me rewrite this, and that's 2.5 minus 3 cubed times 2.5 plus 1. All right. No matter what number this is, when I raise it to even power, it's going to be positive. 2.5 minus 3 is negative. A negative raised to an odd power is negative. 2.5 plus 1 is positive. So a positive times a negative is a negative. A negative times a positive is a negative. So when I choose any real number between 2 and 3, that's going to make this product negative, which is not something I want. Okay? And then I go to 4, x equal 4. So when I do x equal 4, I get 4 minus 2 squared, 4 minus 3 cubed, 4 plus 1. 4 minus 2 is positive. Positive raised to an even power is still positive. 4 minus 3 is positive. A positive raised to an odd power is positive. 4 plus 1 is positive, positive 5. A positive times a positive times a positive is a positive. So we're no matter what real number I use that's greater than 3, when I substitute into this inequality, into this factored part here, it's going to be positive, which is something I want. Okay? So now we know what the solutions are. Okay, so you got to be careful how you write them though, just like we talked in the previous problem. So notice this interval is a solution. Okay? This interval is a solution. So let's now you got to be careful because there's an equal sign, right? So all of those zeros are solutions. So I must make sure I include them in here. I must make sure I include them. All right. So here's what you're going to say. You're going to, and you always go from left to right. You're going to say negative infinity to negative 1 with a bracket because negative 1 is a solution. Because negative 1 made this left-hand side equal to 0, and I'm looking for something that makes it 0 as well. Union. And don't forget that whenever you use infinity, negative infinity is always parentheses with it. What about this 2? This 2 right here. See, that's a number all by itself. That's a number all by itself. So you must say union. Notice I'm using the set notation here. So union the element 2, because 2 is also a solution. And then union, and then from bracket 3 to infinity. So that's how you wrote this. That's how you write this. Okay? All right. And now, let me just say this. Suppose you said, all right, what if we do that same problem without an equal sign? All right, good question. So let's do that. Let me just kind of show you what the difference is. Okay, without the equal sign. So meaning that in terms of this, so all of this is still the same. All of this is still the same except these words here. So when you do this, see there's no equal sign here, right? So when you do this, you're going to say, let me go ahead and rewrite this real quickly. So this is still positive. These are zeros here. This is negative. This is negative. Nothing's changed except that there's no equal sign. So everything else stays the same here. This is positive. Now I want positive, right? So that's going to be this one and this one. So I want this to be positive. There's no equal sign, right? There's no equal sign. So you only want the solutions that make this positive, not 0, only positive. See, this one was 0 as well. So it'll be this, and that's it. So you may say, well, what about this 2? You're not going to use the 2 because 2 is not a solution because 2 makes this 0, but I don't want it to equal 0. So you're not going to use it. So your solution will just look like this. Very simple. It will be negative infinity to negative 1 parentheses. Why is it parentheses and not brackets like it was here? Because negative 1 is not a solution because there's no equal sign. It's a 0, but it's not a solution, so you have to use parentheses. All right? And then you're going to union, and then from 3 to infinity. You're not going to use this 2. You're not going to use this 2 because 2 is not a solution. 2, when you substitute 2 into here, 2 minus 2 is 0. 0 times all of this is 0. But 0 is not greater than 0. So that's it. That's all you're going to use. That's your solution. All right, so these problems were a little bit more challenging. They were a little bit more trickier, I guess, because you had to really think about what you were doing, what the solutions had to be, and how you had to write them. So make sure you just go back over it and try and understand as much of this as possible. But the previous lessons were not as difficult as this one. This one has some little intricacies based with it, some other possibilities you had to think about. Okay, so that is the end of this lesson.